I cleaned my slide up a little bit, but you should see this is exactly where we were a while ago. I was fixing to make this substitution, and what we had started out with was cosine squared. I'll write that down here in the corner. What we're substituting is we had the cosine squared of 2x, and we're going to use this substitution for when theta actually starts out equaling 2x. And so when we get double theta, I wanted you to see that we're going to wind up with 4x. So we'll make the substitution. Here's, my 1/2. And then I have 1 minus the cosine of the double angle of the measure that I started out with. So there's where we are. And I'm going to just continue to copy down everything that I have found so far. I'll clean this up a little bit. That becomes the sine of 2x plus, I can pop my 1/2 out here. And now this is a u substitution. 1 minus the cosine of 4x dx. And I want you to see that this now is a u substitution where u is 4x, du is 4 dx, so I can completely rewrite just this term here, the cosine of u du. So the antiderivative here would be the sine of u plus c. So now I'm going to go back and copy down again 1/4 x plus the sine of 2x plus, here's my 1/2. And the antiderivative of 1 with respect to x is x. And we said the antiderivative for the next term was minus 1/4 the sine of u, and here u was 4x. So there we are. There's our antiderivative function. I'll get this out of the way so you can kind of see what we wound up with there. So here's the antiderivative function. I can clean it up some more. I'll distribute that 1/4 plus 1/4 the sine of the quantity 2x. 1/4 times 1/2 is 1/8 x. Now I have 1/4, 1/2, and 1/4, and it's going to be a minus, so that's 1/32 times the sine of the quantity of 4x plus c. Now, that was a lot of work, a lot of time. So if you have sine or cosine by itself in an integral, and it's raised to an even power, it's not going to be raised to a power much higher than 4. I doubt you ever see cosine to the 6th or cosine to the 8th or anything like that, because it's just going to be so algebra intensive that it's going to eat up way too much time. And remember, the AP exam is trying to test your calculus skills, not your trig substitution skills, not your algebra skills. Now, algebra skills come into play a lot, but they're not going to let the algebra or the trig eat up so much time that they can't test your calculus skills. So we see these where n is an odd power much more often than we see them where n is an even power when they're non-calculator active. Now, if this were a calculator active problem, no problem. I don't care how high you raise it. I can just put that sucker in my calculator. My calculator can evaluate that definite integral. But doing an indefinite integral by hand, you're not going to see these very often. So I'm going to do one more example where n is odd, and then we'll finish up this lesson and you can get started on some homework. So here, instead of our angle measure theta just being x, here theta is 1/3 x. So just a little more complication, but definitely not difficult. Now, this is the case where n is odd. So remember what I'm going to do, and I like writing things like that just because I'm anal. What I'm going to do is peel one off. So there's my angle measure. So again, it's my hope to force that to be du. So I need to put this in terms of sine somehow, right? So I can use u substitution. So this is going to be equivalent to 1 minus the sine squared of the angle measure 1/3 x, sine squared, times cosine of the angle measure 1/3 x dx. And sure enough, if u is the positive sine of 1/3 x, then du, derivative of the outside, not changing the inside, times the derivative of what's inside, and there is du. So I can completely rewrite this in terms of u, that's a minus sign. So this becomes 1 minus u squared du, but du is 1/3 what I need it to be. So I'm off by a factor of 3, right? So pop my 3 out front, u minus 1/3 u cubed plus c, put things back in terms of my original variable, 1/3 sine cubed of the quantity 1/3 times x plus c. So there we go. It's not time consuming. It's not terribly difficult. The peel one off method you will definitely see a lot more often on the non-calculator active questions than you will where n is even. So make sure you can do the peel one off method. But I'm not saying you might not see something as simple as the integral of cosine squared of x dx. They definitely would have you do something like that by hand. So remember, this is where you absolutely have to know those double angle substitutions. Okay, cosine squared of x is equivalent to 1/2 the quantity, 1 plus cosine of the double angle measure. All right, so that you could definitely do by hand, and you will see that by hand. So this finishes up the videos for this lesson. There are just 2 videos. So come to class next time, and we'll work some homework problems on these special kinds of trig integrals.